Hello students, welcome back. Students, in previous lecture we had discussed about semiconductors, and students, uh, we had discussed that semiconductors are of two types: intrinsic semiconductors and extrinsic semiconductors. Now students, we will study some applications of these semiconductors. So first, let me give you a quick revision. Students, we know that silicon and germanium are the most commonly used semiconducting materials. Now students, their electrical conductivity was increased by doping. Now this phenomena is called extrinsic semiconduction. And students, in doping we had studied that silicon or germanium crystal can be doped with a pentavalent impurity, that is a group 15 element, and upon doping with pentavalent impurity we get n-type semiconductor. So we get what type? N-type semiconductor. And similarly, when we dope silicon or germanium crystal with trivalent impurity, students, we get what? P-type semiconductor. Now students, these semiconductors are used, they can be used as diodes. And student, diode is actually what? Diode is obtained by combining a P-type semiconductor with N-type semiconductor. So this is actually a combination of N and P type semiconductors. And students, we use diodes as rectifiers. Now, another use of these is in solar cells, where we use photodiodes, which is also a combination. And in these photodiodes convert light energy into electrical energy. Then students, we have NPN or PNP types materials, where a P-type semiconductor is sandwiched between two N-type, or a N-type semiconductor is sandwiched between two P-type semiconductors. And these type of substances, they are used in transistors to what? They are used to amplify. So they are used to amplify signals of say radio signals. So students, these are some uses of what? Semiconductors. Now students, let me tell you one very important thing, that these silicon and germanium, they are what? They are group 14 elements. And being group 14 elements, they have characteristic valence of 4. They have characteristic valence of 4, which means what? They can form 4 covalent bonds. And students, that is why they have what? They have diamond-like structure. So pure silicon and germanium crystals, they have a characteristic balance of 4 and they have diamond-like structure. Now students, the silicon and germanium, however, we know that they can be used as semiconductors. Now students, we can get semiconductor materials by combining group 12 and group 16 elements. So that means a characteristic valence of 4 can also be obtained by combining elements of group 12 and group 16, or we can have a characteristic valence of 4 in materials which are obtained by combining elements of group 13 and 15. Now, for example, we have zinc sulfide. So zinc is of group 12, sulfur is 16. Then we have cadmium sulfide. Then we have cadmium selenide, then we have mercuric telluride. So students, these are some materials or some solids which also have a characteristic valence of 4, so they can also be used as semiconductors. Now students, these compounds which have a characteristic valence of 4 like silicon or germanium and can be used as semiconductors are called 12-16 compounds. So these are called 12-16 compounds. Whereas students, we have another type of substances which also possess a characteristic valence of 4 and they are obtained by combining elements of group 13 and 15. We have some examples like aluminium phosphide, we can have gallium arsenide, then indium and stibine, that is Sp. So these are what? These are also materials with a characteristic valence of 4 and these can also be used as semiconductors. So students, these are called what? 13-15 compounds. These are 13-15 compounds. So students, the summary of the discussion is that a characteristic valence of 4 can be obtained from these substances or these materials also. These are called 12-16, these are called 13-15 compounds. Now students, there is one important information, that is some oxides of transition metals. Some oxides of transition metals exhibit properties. They exhibit electrical properties like metals. So some transition metal oxides, they exhibit properties like metals. Like I have titanium oxide which exhibits property like metals. Then I have chromium dioxide which also possesses properties like metals. That means these are not metals but they have electrical properties just like metal. Then I have rhenium trioxide. Again, let me tell you students, this substance has electrical properties like copper. But students, there are some other oxides also which have electrical properties similar to metals or insulators depending upon temperature. We have say vanadium monoxide, vanadium dioxide, then we have vanadium trioxide, then we have titanium dioxide, etc. Now students, but properties of these oxides depends on temperature, means these may act as what? Metallic conductors or as insulators depending upon temperature. Means at high temperature these behave like metallic conductors but at low temperature these behave as insulators. So students, this was our discussion about electrical properties. Now students, we will discuss magnetic properties of solids. Students, the next we have magnetic properties of solids. Now students, let me tell you that every substance has some magnetic property associated with it. Now, this magnetic property associated with a substance is due to the presence of electrons, because students, we know that every electron is a tiny magnet. So we say that magnetic properties actually are due to electrons, and electrons acts as a tiny magnet, and it means every electron has what? A definite magnetic moment. But students, now we have to understand that what is the origin of this magnetic moment which is associated with an individual electron. So students, let me tell you that magnetic moments associated with electrons are due to their orbital motion around the nucleus. So they are due to their orbital motion around the nucleus, or this is due to what? Their spin motion. Electrons can spin about their own axis. Now students, what happens is in orbital motion is that, say if this is nucleus, then we know that electrons they revolve around nucleus in well defined circular path. Now students, say if this is an electron, so this is electron. Now students, say this is atomic nucleus. So students, we know that electrons, they revolve around the nucleus in well defined circular path. Now students, the motion of electron around the nucleus is just like a current carrying loop, and we know that around a current carrying loop some magnetic property is what created. So a magnetic property is developed. So this electron will have a definite value of magnetic moment. So this is the magnetic moment. Now students, secondly, we know that electrons, they also have spin motion about their own axis. So if this is the electron, then students, this electron can spin either clockwise or anti-clockwise about its own axis. So students, due to this motion also, electrons have a definite magnetic moment. So the magnetic moment is due to either orbital motion or it is due to spin motion. Now students, let me tell you, since electron is a tiny magnet, the magnetic moment value associated with electron is very small. It is very small, and we express it in units of Bohr's magneton. So magnetic moment associated with electron is very small, and we express it in what? Bohr's magneton. So student, the unit for this magnetic moment is Bohr's magneton. In short, we write BM. And students, let me tell you, one Bohr's magneton is 9.27 into 10 raised to the power minus 24 ampere meter square. So this is the value of one Bohr's magneton. Now students, the total magnetic moment associated with a substance depends on how many unpaired electrons are present, and it is given by this expression. Nu b is what? Magnetic moment, and it is given by this formula n multiplied by n plus 2 under root Bohr's magneton. And what is this n, students? N is number of unpaired electrons. Number of unpaired electrons. So students, we take unpaired electrons. Why? Because अगर suppose एक orbital में दो electrons है, say this is the first and this is second electron, then both the electrons, they have magnetic moments but in opposite directions, so they cancel out each other's effect. So net magnetic moment in that case will be 0. But if electrons are unpaired, then we will have some net magnetic moment, which is given by this expression. So students, this was the origin of magnetic properties associated with what? Materials. Now students, on the basis of magnetic properties, the substances can be classified into 5 different types. The first type of substances are called diamagnetic substances. Second type of substances are called paramagnetic substances. Third type, we have ferromagnetic substances. Then fourth type, we have antiferromagnetic substances. And the last type, that is fifth type, we have ferrimagnetic substances. Now students, will discuss these in details. Students, the first type of substances are diamagnetic substances. Now students, what are diamagnetic substances? So diamagnetic substances are those which are weakly repelled by the magnetic field. So that means diamagnetic substances are weakly repelled by magnetic field. That means आप ऐसे किसी भी मटेरियल को एक एक्सटर्नल मैग्नेटिक फील्ड में जब प्लेस करोगे तो वो मटेरियल मैग्नेट की तरफ अट्रैक्ट नहीं होगा, रादर थोड़ा रिपेल होगा. Now, the common examples of such substances are, we have rock salt, that is NaCl, then we have water is also diamagnetic, then benzene, etc. So students, all these are diamagnetic substances. Now students, diamagnetism होता क्या है, कैसे किसी solid में आता है? तो students, let me tell you that when we place such substances in magnetic field, they get magnetized but only slightly, and that too in opposite direction, which means north south pole जो इस मटेरियल का होगा वो मैग्नेटिक फील्ड का जो नॉर्थ साउथ पोल्स के ऑपोजिट होगा. सो इस वजह से अट्रैक्शन नहीं होगा, रादर व्हाट, रिपल्शन होगा. सो दीज आर देयरफॉर वी से दीज आर वीकली मैग्नेटाइज्ड in magnetic field but in opposite directions, and because of which the magnetic moment associated with the substance will be zero, and hence they are repelled by the magnetic field. Now diamagnetism in solids आप प्रिडिक्ट कैसे करेंगे? So students, it is very easy. Diamagnetism is shown by those substances which have all the electrons paired. Means हर वो material जिसमें electrons paired हैं वो diamagnetic होगा. Why students? Because when pairing of electrons occurs, the magnetic moments of the individual electrons, they cancel out. So the net magnetic moment will be zero. So we say that diamagnetic substances have how many unpaired electrons? They have no unpaired electrons. So we say N is zero, and therefore magnetic moment associated will be, so mu b is magnetic moment, and it is n plus 2 under root Bohr's magnetone. But since n is zero, the net magnetic moment will be zero. So these are the first type of magnetic materials, diamagnetic. Now students, second type we have paramagnetic substances. So what are paramagnetic substances? Now students, paramagnetic substances. So this is the second type. Now paramagnetic substances are those which are weakly attracted, by the magnetic field. Now the common examples of paramagnetic substances we have, say oxygen, we have say ferric ion, we have copper ion, etc. So students, these are some what, paramagnetic substances. Now students, what is paramagnetism? So students, these are those substances which are, when placed in magnetic field, they get magnetized but in the same direction. And therefore these substances have net magnetic moment. But students, let me tell you that these substances, they get magnetized in the what, magnetic field, but when the magnetic field is say removed, they lose their magnetism. So that means paramagnetic substances are not permanently magnetized. They are magnetized only in the presence of magnetic field but lose magnetism in the absence of magnetic field. Now students, third important thing is that paramagnetism in a material is due to the presence of, so it is due to the presence of what, one or more unpaired electrons. That means all the substances which contain one or more unpaired electrons show paramagnetism, because the unpaired electrons have net magnetic moments which get oriented in the direction of applied magnetic field, but when we remove magnetic field, they again what, lose their magnetism. So these are paramagnetic substances, and since they have some unpaired electrons, depending upon how many unpaired electrons, their magnetic moment is given by this formula. For example, say if I say oxygen, students, we know that oxygen has two unpaired electrons present in two anti-bonding orbitals, molecular orbitals. So the magnetic moment associated with oxygen molecule is under root number of unpaired electrons oxygen के पास 2 हैं, so we put 2 plus 2, so this will be 4 into 2 8 under root 8 Bohr's magneton. But students, they lose their magnetism in the absence of magnetic field. That means they are not permanent magnets. Now students, we have third type of materials which are called ferromagnetic materials. So students, third type of substances are called ferromagnetic substances. Now students, what are ferromagnetic substances? Ferromagnetic substances are those which are strongly attracted by the magnetic field. So these are attracted but strongly. So these are attracted strongly by magnetic field. And students, common examples we have iron, cobalt, nickel, gadolinium and chromium dioxide. Students, these substances are permanently magnetized. So that means these act as permanent magnets. Means once they get magnetized, they become permanent magnets. So they are permanently magnetized. So they are permanent magnets. Now students, I'll explain you how this property arises in a solid. So students, in ferromagnetic substances, the metal ions can be grouped together into small regions. So listen carefully that in any ferromagnetic crystal or any ferromagnetic substance, the metal ions can be grouped together into small regions called domains. Those small regions are called domains. And students, these domains also act as tiny magnets, as they have a definite magnetic moment associated with them. Now, in unmagnetized ferromagnetic substance, these the magnetic moments of these domains, they are randomly oriented. But when such substances are placed in magnetic field, the magnetic moments of the domains, they get oriented in the direction of applied magnetic field. That means they get oriented in the same direction. So say if we have 6 domains, and when we place such materials in magnetic field, the magnetic moments get oriented in what? Same direction. As a result, students, these substances have very high net magnetic moment. And the important thing is that when we remove magnetic field, these magnetic moments of the domains, they get oriented, or they remain oriented what? In a ordered manner. That means the ordering of magnetic moments of the domains persists even in the absence of magnetic field. And that is why, students, these substances are called ferromagnetic substances. So the most important thing is, in ferromagnetic substances, the magnetic moments of domains, they are oriented in the same directions. That means they get oriented in the direction of applied magnetic field. Now students, we have next type, fourth type, and they are called antiferromagnetic substances. Now the most common example of antiferromagnetic substance is manganese oxide, monoxide. Now students, these substances also have a domain structure similar to ferromagnetic materials, but in antiferromagnetic substances, the magnetic moments of domains, they are oriented in compensatory way. That means they are oriented in compensatory way, means like we have both parallel and anti-parallel directions of magnetic moments. But see, magnetic moments of this domain and this domain is cancelled out. इसका इसके साथ cancel हो जाएगा, इसका इसके साथ cancel हो जाएगा. So the net magnetic moment is 0. So students, such substances which have arrangement of domains in this compensatory way so as to give zero net magnetic moments are called antiferromagnetic substances. Now students, last type we have ferrimagnetic substances. Ferrimagnetic substances. Now students, in ferrimagnetic substances, the magnetic moments of domains, they are oriented in, again, both parallel and anti-parallel directions in magnetic field, but in unequal numbers, which means, say, these two are oriented in upward direction, yeah, downward. Then we have these two in upward. So we have what? The magnetic moments of domains oriented in both parallel and anti-parallel directions, but in unequal number. Means you see 1, 2, 3, 4. So 4 domains have magnetic moments in upward directions, only 2 have in downward. So here the magnetic moment will be greater than 0. Now, so these are called ferrimagnetic substances. Now students, the common examples of ferrimagnetic substances are magnetite, that is Fe3O4, then ferrite like Mg, Fe2O4, or zinc ferrite, ZnFe2O4. So these oxides are called ferrimagnetic substances. Now students, one important thing, that these substances lose their magnetism on heating and thus they become paramagnetic. So students, this is very important, that when we heat these substances above a particular temperature, they lose their magnetism and become paramagnetic. And the temperature at which this occurs is called Curie temperature. So student, this is the 5th type. And students, we have now finished magnetic properties of solids. So the last topic of this unit is now dielectric properties of the solids, which we will discuss in next lecture. Thank you students.